Hi everyone, it's Mr. Zarzik here, and in this screencast I'm going to show you even more examples of how we write loop equations using Kirchhoff's voltage and current laws. Alright, so let's get going. Alright, look at this. 4 voltage sources, a whole bunch of resistors. This is pretty complicated. Alright, just doing at a quick glance at this, I can see at least 3 potential loops in here, which is good because there's a lot going on. When I'm trying to figure out how to set these things up, here, let me zoom in just a little bit. Okay, I know I got to identify all the currents, so my mind is going to go towards just trying to find any currents that go through more than one resistor. Okay, that's just as a starting point. It's just where my brain goes. So like I see here that this 25, 15, and then this 8-volt source are all in series with one another. I'm going to call that one I1. Okay, and already just right there I've got most of a loop. So next step is draw a loop. Okay, so I think for this one I'm going to wind up starting here. Where I start's completely arbitrary. It's just like a reference point for myself when I'm working these. So I'm just going to go around and I got a loop. When I'm writing my loop equations, I need to be consistent. In other words, I don't want to have conflicting directions of current flow in the loops that I draw. So this little yellow loop that I have, it's going around clockwise here. It butts up against this middle section. So if I'm going to do a loop in here, well, that means I need to be consistent, which means that the current still got to flow downwards through that 20 ohm resistor. So like if I would just draw the loop, I would need it to go around kind of like that. Okay, so we can see like over here, all right, that the current is flowing downwards, just like it is in my first loop. All right, and then just from that, that also means that there's got to be current flowing upwards through that 5 ohm. Here, let me mark a couple of these just so we can see. So I have like some current going down in this direction here, okay, which is consistent for both loops. All right, I'm going to wind up with some current going up over here. All right, through that, I guess just to be thorough or diligent, I don't know, whatever you want to call it, like there'd be current flowing that way. I know that's kind of weird, that's flowing backwards through the voltage sources. Sometimes with these, that's just what happens. Okay, what are you going to do? Okay, we got to stay consistent. That's all that matters. All right, so then we go over to this last little branch here. Okay, that orange arrow is going upwards. So that right there already tells me that the direction that my loop has to travel, so that when it hits that orange branch, it's going upwards. So that means it's going to go around like that. Okay, so what other currents do I see going on here? Well, then let's see. This voltage source here on the right is in series with this voltage source, okay, which is in series with this resistor. Okay, and see, notice that the 2 negative terminals of the 2 voltage sources are butted up to one another. So these 2 voltage sources are in opposition. Somebody put one battery in backwards. Okay, I'm going to call that one. Let's see, what should I name all these? Let's make the red one. Let's make that one I3. I think I don't even have an I2. We need an I2. Here's an I2. Okay, let's make the orange one. I didn't name the purple one either one. That's I4. Okay, and then we'll make the orange one over here. We'll make that one I5. Great. All right, so many colors. Okay, and then the loops, I'll do. Okay, there's no rhyme or reason to the way I labeled the current, so let's make that loop 2. And this loop 3. Why not go 1, 2, 3? Why 1, 3, 2? It doesn't matter. Okay, because I want to. All right, now let's write some equations. Okay, remember the numbers are just arbitrary. Okay, they're just there so we can write some terms. All right, so KVL. Okay, so the rises and the drops in the loop have to add up to 0. Okay, so what do I got? I got 8 volts. That's my source. All right, then I run into this, what is that, 20 ohms with I2. Here, 20I, that's enough. It's back here. We're doing that. Okay, and then, let's see, so we run into the blue. So that's, what is that, I1 and negative 25. Okay, and then, what is that, 15. So 15 I1, and then I'm back to the star. So if I just quick mental check here, okay, 1 component, 2 components, 3 components, 4 components, 1, 2, 3, 4 terms in my equation. All right, I can do a little bit of simplification, not much. All right. I could also label which current that is, sorry. That's minus 40 I1. Okay, and not necessary, but I'm going to do it anyway. I'm going to factor out a 4 from all these because I want to. So let's see, 8 divided by 4 is 2. 20 divided by 4 is 5. And again, you don't have to do this step. You could just leave it as it is. I don't even know why. Now I'm like second guessing. Like, why did I do this? But it's too late. I did. So there we go. Okay. I have an equation. All right. I need to write more equations, so I'm going to put this up over here. That's too big, so we'll make it smaller. Okay, we'll come back to that later if we need it. We're going to need it. All right, now let's go ahead and do loop 2. Loop 2, the great loop. All right, so let's see. Where should we start here? Let's start over here. All right, so then we got 2 volts. All right, and we're along the purple track. So what do we got here? Minus 10. What do I call that? I4. All right, and then it's I5 going through that 5 ohms. So minus 5, I5. All right, and then we hit the 4 volt. But notice that the 4 volt is wired in backwards. So then we got to subtract it. I know that's weird, but we got to do what we got to do. Why would you do this? I don't know. We just did. All right, so then quick mental check. 1, 2, 3, 4 things, and then 1, 2, 3, 4 terms. All right, that looks good. All right, I don't think I could, well, I can put the 2 and the minus 4 together, so at least I can do that. So that'd be 2 minus 4 is negative 2, and then the rest stays the same. All right, so I got another equation. Great, another equation. Oops. Let's go put that with its buddy up here. Shrink it down. All right, let's keep going. Loop number 3. All right, where should we start now? Doesn't matter. Let's start with the resistor. Maybe I'm avoiding the voltage source that's backwards. Don't judge me. All right. I can start anywhere. I have to deal with it eventually. So let's see. So it'd be 20 I2. Okay, and then I loop around, and then that's that orange one. Minus 5 I5. And then I get to that voltage source. It's got I3, but I don't need current, and no resistance is listed. So all I got to do is just minus 6 volts. Oh, that's so weird. Doesn't matter. We're doing it anyway. Okay, it's what we got to do to solve the problem. All right, there's no simplification that I can do there. Nope. Equation 3. All right. Same thing. Go over here with your friends. All right, now if I do a quick inventory, all right, so if I do a scan, let's see, equation 1, I2 and I1. I4 and I5 in equation 2, and I2 and I5 in equation. So it looks like in terms of my unknowns, all right, what do I got here? So I got I1, I got I2, I got I4, I got I5. Ugh. 3 equations, 4 unknowns. I think I might need some more equations. I'm out of loops. I could try to do this external loop. Yeah, no, things are already going in opposite directions. Like, that's not going to work. No. So I go to KCL. Okay, current law, which means find the junctions. Okay, where we know the current going in and current coming out. So, like, there's one. All right, let's look at that one. So I1 and I3 go in. I1 and I3. Enter. 1 current leaves. I2. All right, great. So now I've got another equation, except that has I3 in it, which got me another unknown. Oh. Find another junction. where we know the current going in and current going out. That's that other little dot right there. I can do that. All right, so I5 goes in. What comes out? I3 and I4. I4. Okay, so with those equations, those both contain I3, so we can get rid of I3. The way that we get rid of I3, you know this. All right, we're going to take both of those equations and just rearrange them so they say I3 equals. All right, so that in order to do that, I have to subtract over I1. All right, so I'm going to wind up using this one. I'm going to set it equal to what we've got going on down here. So then let's take and rearrange this. So subtract I4. Okay, I'm going to use that one too. Okay, those two things both equal I3, which means we get to set them equal to one another. So that, which equals I3, is equal to that. All right, and now I got another equation with I1, I2, I4, and I5. That's my equation 4. All right, so now I'm staring at 4 equations and 4 unknowns. Ugh, it's a lot of algebra. Okay, so if you want to solve it, you'd have to do a lot of algebra. AP would not ask you to solve this big of a systems of equations. That's just too much. You'd spend the entire AP test doing algebra. Okay, and that's not what they're testing you on. They might ask you to set something up. That's possible. All right, typically if KVL and KCL show up, it's going to be in a simpler circuit, but if you can kind of walk through this one, then you're prepared. All right, there is a trick to combine these equations using your calculator. So if you're good, I will make another video to show you how to use the matrix function on your calculator, but that's for later. All right, so moving on from this example, all right, it's easy to kind of get lost in this, so I wanted to show you one that is less mathematically disgusting, but also still kind of gross. All right, sometimes you will run into this, all right, where when you set up your loops, you wind up with current going the wrong way through everything. So what I mean by that is for this simple circuit, I think making loop A is very reasonable. You look at the 8-volt source, okay, and you say, all right, look, the 25 and the 15 ohm resistor are in series. You know, it's like all this stuff. So I1, like we played this before. Okay, so fine, like make loop A, great. But that means we got to have loop B, okay, go around, be consistent. So group B goes around, and we say, all right, great. So then this current that's flowing through this thing, I guess it's only flowing through this. I'll call it I. No, I'm doing it. It goes through all this. This would be all I2. Okay, and then like, oh look, I1 and I2 would come together and flow through the 20 ohm. We'll call that one I3 and the voltage source. Okay, so like if I just wrote my loop equation for loop A, no big deal. All right, let's start over here. What about all the colors? Okay, that's enough colors. So we get 8 volts. Okay, fine, I'll do some colors. Minus 20 I3, and that would be minus, apparently I'm writing the loop equations for this one too. I wasn't going to do that. I was just going to talk about it, but I'm doing it. All right, so assuming, let's see, I didn't mess anything up there. 8 and minus 20 I3, and then what do we got here? Minus 40 I1. Great, okay, so I could divide out, I'm not going to divide out, let's just leave it alone. Okay, so that one looks fine, no big deal, nothing weird. But then when I go over to loop B, then it got weird, okay. Well, now look at this. Start where it doesn't matter where you start. Here, let's start over here. Every term in this, minus 20 I3, and then that's 6-volt batteries. It's wired backwards. So we're backfeeding the battery that has current dissipating voltage, and then it drops even more, and then what's left? You get What we got here? We got 5 ohms times I2. So a voltage drop, a voltage drop, a voltage drop. We know that that can't be right. They're all drops. So does that mean that our equation's wrong? No. There's nothing wrong with our equation. Like mathematically, this is just fine. Okay, it's a consequence of having to set up our KVL loops consistently. When we solve these things, all right, we're going to get one of these answers, I1, I2, I3. Something's backwards. We know that something's backwards. How do we know this? When we solve it, currents are going to come out negative. Okay, which ones? Well, we got to do the math. One or more of the currents is going to come out negative. Okay, no big deal. All right, we try to avoid these whenever we can. Honestly, when AP gives you these circuits, they give you ones that tend to avoid stuff like that. But you never know. Okay, if we've come this far, so here, if we needed to get one more equation, just so we can say we did it, here, KCL. I'm not even going to color code. I1 and I2 go into this thing, I3 come out. Okay, set up your systems of equations, solve it. You can solve this one. It's not so terrible. It's not like the last one. You'll see that some of these currents come out negative. All right? Well, anyways, thanks for watching, and I'll see you next time.